right, so we are starting graphic quadratics. We are looking at day 2. So we are really just expanding upon our knowledge from day 1. And on day 1, we focused on stretching, compressing, and reflecting. So a graph of an absolute value is similar to a graph of a quadratic in that the a value of both will affect those transformations. Today, we're going to focus on the h and k transformations, which are the horizontal and vertical shifts. So again, quadratics and absolute values are similar in that their transformations of h and k affect them the same. So essentially, we want to know how is a graph transformed from its parent function, what is the formula for the vertex, and how do you find the axis of symmetry. So what we're going to do today and tomorrow is compare vertex form to standard form. So we are comparing vertex form to standard form. And there are some pros and cons to each. Vertex form is y equals a, parentheses, x minus h squared plus k. Standard form is ax squared plus bx plus c. When graphing the two forms, each one has a kind of different way of being better for graphing. So when graphing a quadratic in vertex form, you can easily see the key points about its graph. When graphing from standard form, it is much more easily done on a calculator and can use a calculator to find our key pieces of information. Okay. And then we are going to compare the two equations. So again, you have vertex form and standard form. You don't have to rewrite that. I just put it up here again so I can reference them. The vertex and vertex form you can easily see as h and k. So the vertex in vertex form is easily seen. Standard form requires a formula. Standard form requires a formula. So in standard form, the vertex is negative b coming from the bx term divided by 2 times a. And then to find the y value, you have to find the x value, plug it back in, and solve. The axis of symmetry is always the x-coordinate of the vertex. The axis of symmetry is always the x-coordinate of the vertex. The y-intercept in standard form is easily seen as c. So y-intercept in standard form is 0, comma, c. The y-intercept in vertex form requires you to plug 0 in for x and simplify. The max or min is the y value of the vertex. The max or min will occur at the y value of a vertex. You will have a max if your a value is negative and a min if your a value is positive. You'll have a max if your a value is negative and a min if your a value is positive. Okay, so when we're translating a parabola, like I said, we focused on stretching, compressing, and reflecting on day 1. For day 2, we are going to focus on horizontal and vertical translations. A horizontal translation occurs on H. If H is positive, then it goes to the right. If H is negative, it goes to the left. And just like our absolute value, that minus is not part of the positive or the negative. So an x minus 3 in the problem would actually move right 3. The vertical translations are the movements up or down. The vertical translations are the movements up or down. And then you can have horizontal and vertical movements. So you can have both horizontal and vertical movements. Okay, so what we're going to do is interpret the movements of our graph without graphing it until we get through all of the key pieces of information. So we're going to always start with identifying our A, H, and K. So the A value is 3 because it's what's in front of our vertex. My H value is a positive 4 because the formula is x minus. Therefore, my H is 4. My K value is negative 2. So A is 3, H is 4, K is negative 2. My vertex is H comma K. So in this case, 4, negative 2. The axis of symmetry is x equals 4. this graph has a min because my A value is positive. So the graph opens up like a smile. So a smile will have a min because it has a low point at its vertex. So it'll have a min at K, which was -2. The domain of a quadratic is always all reals. The domain of a quadratic is always all reals. Because that graph is continuing infinitely in the positive or negative direction on y. So again, the graph has a domain of all reals. The range value is always related back to the k value. The range value will always be related back to the k value. So in this case, since it's a min, my y's are greater than. So a min will have greater than, a max would be less than. So my y values are greater than or equal to k. So the range will always have information pertaining to k. So if you get the vertex right, you'll get all of the key pieces of information right. That is why it is so critically important to identify A, H, and K correctly. So once again, we look at our equation and we identify A, H, and K. The A value is -2, the H value is -1, and my K value is 4. So the A value is -2, the H value, is -1, and our K value is 4. So we're going to use those key pieces of information to identify my vertex, axis of symmetry, my domain and range, and if I have a min or a max, etc. So first thing we always want to identify is our vertex. So my vertex is at -1, 4. Again, your vertex is always H, K. Then I'm going to identify my axis of symmetry, which goes through the vertex. That is at x equals -1. And then I need to determine, do I have a min or a max? So since A is negative, my graph is reflected. So a reflected graph will open down like a frown. Therefore, I have a max. And my max is at K, which is 4. Remember that domain is always all reals. So last time I wrote it using the infinity symbols. This time I wrote it using the symbol for all reals coming from our integer set symbols. So that is an R with a double line. And my range, since I have a max, will be less than or equal to my K value, which is 4. So the last thing we want to look at is writing an equation in vertex form. Do you have this at the bottom of your notes packets? You have example 3, don't you? Okay. So this is a little tricky because this is where we have to go about identifying a missing value. So we are going to be given a key piece of information. We are given the vertex. So that means I can substitute the vertex in for h and for k. So if I'm given the vertex, I can substitute the vertex in for h and k. So that's where the 3 and the 7 is coming from. I'm also given a second key piece of information, which is a point. That point represents the variable values x and y, because a point comes from the coordinate system x comma y. So what I'm going to do is plug in h, k, x, and y to the vertex form of my equation. So I'm going to plug in 4 for y. I don't know a. I'm going to plug in 9 for x, 3 for h, and 7 for k. Once I've plugged those key pieces of information in, now I need to simplify following order of operations. So the order of operations say I have to simplify inside my parentheses before I multiply or square. So 9 minus 3 is 6. 6 squared gets me to 36. So I have 4 equals 36a plus 7. Subtracting 7 from both sides, I get negative 3 equals 36a. And then what I'm going to do is solve for a, where I get negative 336. So now I have h, I have k, I found a, so I can get the equation of this quadratic by replacing y and x with their original x and y values of x and y, replacing a with the value we just calculated of negative 112, h with 3, and k with 7. So you can use the vertex and a point, much like we did for linear functions and found slope. This a value represents the slope of a quadratic. That a value is kind of like the slope of a quadratic. It tells me how quickly my graph is changing. So just going back through what each of those variables mean and relating it back to absolute values. A negative is reflection. 1/12 is compressed. A positive 3 is right 3. And a positive 7 is up 7. So if it asks you for the transformations, that is the words for what a, h, and k represent. So it would be reflected, compressed, right 3, up 7. So your homework is very similar to all of those examples. I am looking for you to identify all of the key pieces of information of absolute values, of quadratics. Again, all of those key pieces of information directly relate back to what we learned for absolute values. You will be graphing some of these on the back as well. So you can make tables when you graph, or you can plot points. We're going to get more and more into graphing as we go and identifying more key pieces of information.